Okay, so today we're going to get a little practice in predicting the products for the 5 major types of reactions. So if you want to go ahead and pause the video and copy these down, that would be great. And also if you want to go ahead and try and solve them on your own and then just go back and double check against my answers, that's good as well. And I'll go through and talk through each of these reactions. Okay, so you can go ahead and pause and copy down now. Okay, so now that you have them copied, the first thing I like to do, and the first thing you'll often be asked to do, I didn't ask you here, but I would in an assessment situation, is to label each of these reactions based on what type they are. So let's go through and do that first. Let's pick out the easy ones first. So number 2, in my opinion, is an easy one to label. There is only one reactant. So if there's only one reactant, it has to be a decomposition reaction. Okay? Also, in my opinion, number 5 is an easy one. I have a hydrocarbon plus an oxygen. So I have a combustion. Then number 3, if you write combustion, that's okay. You have the addition of oxygen. Or if you write synthesis, that's perfectly okay as well. They could fall into both categories there. So if we look at number 1, we have an ionic compound solution plus a single metal. Okay, so that is the pattern for a single replacement reaction. Then for number 4, we have solutions of 2 ionic compounds, so that falls into the double replacement category. And so now that I go ahead and do that first, that saves me a lot of work, because now once I get to each problem, I can focus in on that specific type of problem and what I do there. Okay, so let's look at number 1 first. Hopefully you remember, for a single replacement reaction, we need to first consult the activity series. We need to see if aluminum is more reactive than mercury. So is aluminum able to replace mercury? So I go to the table, I find that aluminum is further to the left than is mercury, so it's more reactive. So aluminum can replace mercury here. So we'll have aluminum, and I'll just write aluminum chloride. So then I check my charges, plus 3, minus 1, so I cross them. AlCl3 plus my leftover metal, mercury, okay, Hg. We won't worry about phase symbols here, especially since mercury is the exception. It's a liquid metal, so we won't worry about that in this situation. But I will need to worry about balancing here. So I have 2 chlorines and 3 chlorines, so I have to make the 3 have to make the 3 even. There's no way to make the 2 odd there. So I put a 2 right there. I put a 3 right here. So then for mercuries, I need 3 mercuries on this side, I need 2 aluminums on that side. Okay? So this reaction did actually happen, so I wrote it out and predicted the products. So 2, I have a decomposition reaction, so I see that a metal chloride is not one of these special patterns. Okay, metal chlorates are, but metal chlorides aren't. So if it's not one of the special patterns, we simply break the molecule apart. So I'm going to have iron plus chlorine. Okay, so iron will be a solid here. If you thought that might be enough heat to melt the iron, you should put a liquid. That's okay. That's a little bit of a stretch to make that assumption though. As long as you don't put aqueous there, that would be wrong. So then chlorine, remember, is special, is diatomic. So Cl2 is a gas. We have chlorine gas. So I need to go back, same situation here in balance where I have 3 and 2. So I need to put a 2 there and a 3 there. And I put a 2 there. So I'm all balanced up. Okay. For the third type, I just have either the combustion of a metal or a direct union synthesis. Either way, you just stick the atoms together. So AlO, check my charges, plus 3, minus 2. Those don't cancel, so I cross my charges. So Al2O3. So I need to balance this now. I can put a 2 here, I can put a 3 here, and I can put a 4 here. And that would be a solid. If you don't put that would be perfectly okay there. So none of those none of those coefficients cancel or reduce. We're in good shape here. So double replacement. I know that the metals are going to swap places. So I know I have to check the solubility table to see if it actually happens, but I know I need to write the products out anyway, so I'll go ahead and do that. So I'll go ahead and take lithium and nitrate, LiNO3. Lithium's plus 1, nitrate's minus 1, I'm in good shape. Plus copper. phosphate. I can't look at the periodic table and find copper's charge, but I know here nitrate's -1, so copper has to be +1 in this situation. So I have +1, -3, so I have Cu3PO4. So now I go back and check my solubility rules. So for nitrates, I see nitrates are always soluble, no exceptions. So I have AQ. Then I go to the rule for phosphates. So phosphates are insoluble, except for alkali metals or ammonium. So that's why this phosphate was soluble, because lithium is an alkali metal. So if phosphates are insoluble and copper 1 is not an exception, I get a solid there. Okay, so copper 1 phosphate is my solid product there, so the reaction actually happens. So now I need to go back and balance it. I can put a 3 here and a 3 here. So now the reaction is all balanced and I'm good to go. Then for the last one, I need to write the products for the combustion of a hydrocarbon. So I know they are CO2 gas plus H2O gas. Okay, so I really don't even need to think here, because I know that when I have the combustion of a hydrocarbon, I always get the same products. Okay, so then to balance this, I will use a 5, a 3, and a 4. So we'll go back and double check it. 3 carbons, 8 hydrogens, 10 oxygens, 6 plus 4 is 10 oxygens. So I'm in good shape there. Okay. So those are examples of the 5 types of reactions, simply predicting the products and balancing. So let's look at 5 more, where you have to go from the word equation to the chemical equation. So go ahead and pause the video, copy these down, and either try them on your own, or after you copy them down, come back and work through them alongside me here. Okay, so now that they're copied down, let's go ahead and let's just do these one at a time, and before we solve each one, we'll label what type it is. So the first step when you have a word equation, you want to put that in a chemical equation, is go ahead and get the symbols for your reactants down. So go ahead and get the symbols for your reactants down before you even determine what type of reaction it is. So this one I have solid sodium. So remember, it's important, if the problem tells you a phase symbol, to write it, is added to a solution of potassium chloride. So KCl plus 1 minus 1, I'm in good shape. AQ. So now hopefully we recognize this is a single replacement reaction. Okay, so for our single replacement, I need to go consult the activity series. I see if sodium is more reactive than potassium. So in other words, I'm asking, can sodium replace the potassium here? Okay, so hopefully you see that potassium is further to the left than is sodium, so that means sodium is less reactive than potassium, so the reaction does not happen. So I simply have no reaction here. And I can put the X over the arrow, whatever you want to do to show that. So that one's fairly straightforward. And the next I have solutions of sodium sulfide. So Na2S, and it's a solution, so it's AQ, plus aluminum acetate, so AlC2H3O2. There's 3 of those because it's plus 3 minus 1. And that's also aqueous. Okay. So I have 2 solutions of ionic compounds, so that is a double replacement reaction. So I know I need to predict the products first and then determine if it actually happens. Let's go ahead and write the products out. So first let's write out sodium acetate. So NaC2H3O2. Notice I don't need the parentheses here because there's only one acetate polyatomic anion present. Then I have aluminum sulfide, so AlS. So I have plus 3 minus 2, so Al2S3. So now I can go back and check my solubility. So sodium acetate, acetates are always soluble. I see in the periodic table, or the solubility table, not the periodic table, excuse me. So I get an AQ. I would have plus. I can go check these sulfides. Sulfides are insoluble, except for group 1A, group 2A are ammonium. So aluminum is not an exception, and they are insoluble. So Al2S3 would be my solid product there. Okay. Then if I have a solid product, I know the reaction actually happens. Okay. So we can look at number 3. Solid zinc is added to a solution of copper 2 sulfate. So I have zinc solid, copper 2 sulfate is CuSO4. It's a solution, so it's AQ. So I have +2 -2, so I'm in good shape here. Hopefully I see a metal plus a solution here would be a single replacement reaction. Okay, so the metals just switch places if zinc is reactive enough. So we check our table. Is zinc more reactive than copper? Yes. So we see that zinc is reactive enough to replace the copper. What's the charge of zinc? It's a transition metal, right? Well, actually, remember that zinc does not have a variable charge. Zinc is always +2 when it forms a cation. So I have zinc sulfate, so +2 -2, so I'm in good shape there, plus copper. Okay. So if we go back and check the solubility table, if we wanted to go that route here, we see that sulfates are soluble and zinc is not an exception. So I could put AQ here, and I can put solid for copper. Again, those phase symbols aren't the most important thing in the world here. They're far more important for the products of double replacement reactions. Okay. So 4 is a little bit of a strange one. It says sulfur trioxide is bubbled through water. So if something is bubbled, what state of matter does it have to be? Yeah, it has to be a gas. So I can have SO3 gas plus H2O. I know water's always a liquid. Okay? So hopefully you recall one of the synthesis patterns that we learned was a nonmetal oxide plus water. So when you mix a nonmetal oxide plus water, remember you get an acid. But there was a little bit of extra step here. When you have a nonmetal oxide gas, you have to go to the gas ion chart to see what ion it produces when it's dissolved in solution. So I should have labeled this synthesis. I apologize. You just have to recognize this as one of the patterns for a synthesis reaction. So if you go to the gas ion chart, SO3 gas corresponds to a sulfate. Okay, so an SO4 with a -2 charge. Okay, so then if it's -2, we know an acid starts with a hydrogen. So then when you have the -2, tells us we need 2 hydrogens. So H2SO4, and that would be aqueous. Okay, so sulfuric acid there. I could go back and balance it, but it's already balanced, so I'm in good shape. And the last one, iron 3 chlorate is heated. I'm running out of room, I apologize. So let's go down here. So let's say iron Fe chlorate, ClO3. So if iron is +3, chlorate's -1, I have that. It's heated, so I draw the arrow. Remember to put the triangle showing heat there. So then remember, this is one of these special decomposition type reactions. So when a metal chlorate decomposes, I get a metal chloride. So my metal was iron chloride. So I have +3 -1, so I cross my charges. FeCl3 plus, hopefully remember the other product was oxygen, so O2 gas. And then I could say, it didn't say in the problem, but most likely in the problem say iron 3 chlorate solid. If it had said that, I could put the S here and the S here as well. So then I could go back and balance it. So I have 3 chlorines, I have 3 chlorines, I have 1 iron, I have 1 iron, but then I have 9 oxygens. Okay, so if I have 9 oxygens, there's no way to turn 2 into 9, so I need to double that there. So now I have 2 irons, so I need to put a 2 there. So now I have 6 chlorines, I have 6 chlorines, so now I have 18 oxygens, so I need to put the 9 there. So because I use larger numbers, I need to go back and double check myself. 18 oxygens, 3 times 3 is 9, times 2, 18 oxygens. Okay, so I'm good there. So those are examples of the types of problems you'll see. These are likely easier because they give you the reactants written out. These are slightly more difficult because you have to first convert the words into a problem like this and then solve it. So don't forget to label each type of problem. That makes it a little bit easier. And then down here, if I ask you to write the products in words, you could very easily do that. So the products in words for number 1, we don't have any. For number 2, we'd have sodium acetate plus aluminum sulfide. The products for number 3 in words, zinc sulfate plus copper. The products for number 4 in words would be sulfuric acid, and the products for number 5 in words would be iron 3 chloride plus oxygen gas.